Okay, so today we're going to be solving proportions. We're solving proportion. Basically what we're saying is as one value increases, the other value increases proportionally or at the same rate. And we've got to find that rate or how that works. This is no different than if I bought an 8-ounce bag of Doritos at Dillon's. Is that cheaper, or how much should I expect to buy if it were a 12-ounce bag? The price, whatever the price of the 8-ounce bag, should increase proportionally. Now, in the real world, if you go to Dillon's, that doesn't always happen. We'd like to think buying in bulk actually saves us money, but it doesn't at all times. So you've got to kind of check the unit price and do the math for yourself. Today, we're going to be solving proportions, and they'll try to apply it to those kind of situations I previously discussed here in just a bit. But you got to understand the math. So what they do is they will give you problems, and I'm going to give you two specific problems in which we will eventually evolve into solving a proportion or direct proportion, a fraction equal to a fraction. So right now it doesn't look like a fraction. We're going to take a number times what? And we want it to be 15. Well, in math we don't do what. What is a variable? It's a letter. We can pick any letter we want to. So really I'm going to transpose this. It's going to be 3 times n is equal to 15. Or realistically that could just be 3 butted up against n is 15. Now, eventually we're going to get to problems in solving proportions today where this looks very similar to our problems. So we have to understand where they're coming from, what it means, and how to get from point A to point B. Well, we take that equation, 3 times n is equal to 15. And we've got to understand some key principles. We're not solving for 3n. We're solving for n. We want to know what it is. And some of you may have already figured that out by now, but I'm a little slower than most. So here's how we're going to work that. Because I know in the previous slide that this is 3 times n, in order to separate my n and get it by itself, I must divide by that 3. And when I divide by that 3, I get 3 over 3, which is simply 1, times n, which is n. Now, to maintain equality, I have to do the left side just exactly the same as I do the right side. So since I've divided the left side by 3, I got to divide the right side by 3. And that guy reduces. 15 divided by 3 is 5. So n is 5, and that's the goal. That's what we were looking to get. Now, we will see that evolve as we do our proportions and solving for proportions later on. There will also be one more thing. So as we look at another problem, let's say 2/3 times n is equal to 10. Well, fractions always seem to be a problem with most people, and really if this is where math really evolves into what we're trying to teach you as far as a critical thinking perspective. We need to know what's going on, how it's going on, and be able to look far enough forward to where we can predict and not waste our time on the little things. Because if we solve this problem just as we solved the previous problem, we know that 2/3 is a quantity times n. To get it off of that, all I have to do is divide by 2/3. And our rationale behind this is anything divided by itself is still 1. So anything divided by itself is still 1. Well, when I do to the right side what I just did to the left side, now what? I've got 10 divided by 2/3. And here, again, we're dividing fractions, which is that copy dot flip. If I knew that from the start, I wouldn't quite waste my time doing this problem this way. So let's start this problem over. Let's go 2/3. N equals 10. I want to get that 2/3 off there. I am dividing fractions. So I'm dividing fractions. Copy, dot, and flip. So if I multiply by the reciprocal, which is that copy dot flip phrase or whatever you've probably been taught in junior high school, okay, it works. 3 divided by 3 is still 1. 2 divided by 2 is still 1. It leaves me with n. What I do to one side, now I do to the other. And I've already foregone that step where I had 10 divided by 2/3. I have to copy dot flip that, which makes it 10 times 3 halves. I've already done that step. So now all I have to do to get this end value, I can reduce first. So 10 over 2 is 5 over 1. And 1 times 1 on the bottom gets me 1, which doesn't really matter because 5 times 3 is 15. And we're saying that 2/3 times 15 is actually 10. And it's nice with the algebra, and this is what we're starting to do here, is we're actually starting to do some algebra, solving for an unknown, is we can plug it back in, and 2/3 of 15, or 30 over 3, is 10, is still equal to my right side of 10. All right, so now we're ready to start proportions. I'm going to do a couple problems on proportions. Now, if you remember, we did a section on proportions earlier. And when you recall, there was a lot of different ways to look at those formulas, or to look at these proportions. So here's a proportion. I've got a fraction, 6 over n, is equal to 3/8. Now, we talked about being able to build them up, break them down, unit rates, or we can do a cross products type scenario. So you have different options here. And if you see it, chances are what you're seeing is right. All right? Cross products works every time. So I'm going to leave that for my next couple problems. Right now I'm looking at a 6 on top and a 3 on top in my numerators. And if I can look at this, I know that 3 times 2 is 6. Well, that's great. So there's times 2. When I do the top, I got to do the bottom. So if 3 times 2 is 6, then 8 times 2 has to be whatever n is. In this case, n then is 16, because 6/16 does equal 3/8. And this is what I was talking about before, about plugging things in. If we had a common denominator of 16, 8 times 2 has got to be 16. Well, I do the top or bottom, I do the top, and now I get this guy to be 6/16, and 6/16 equals 6/16. Left side equals right side. So I know now that my answer of 16 is correct. All right, and I can do that with every single problem that I do. And you've got time for your quiz. After your quiz is done, you still have time allotted, go ahead and check your work, okay? And definitely on your tests as well. So let's look at another problem. So I've got 12 over 40 is equal to something over 25. Now, as you see, my 40 decreases to 25, but it's not like it's divide by 2 or divide by 4 or divide by 8 or whatever. It just doesn't quite work that way. Now, yes, there is a number there, but it's a fraction or a decimal or who knows, okay? So if I don't really want to worry about that, cross products does work every time, and I told you I would do that on these two problems. So I'm going to cross products. So I'm going to take this 12 times 25, which is this cross, numerator to denominator. And then I'm trying to make everything horizontal. So my equal sign, and notice everything falls on a line here. And now I'm going to take my other cross product, which is 40 and n, which is 40 n. Now, here's where I do some things a little different. Because I can, yes, simplify the left side in 12 times 25. So, yeah, that becomes what? 300. I really don't care because I'm solving for n. And the bigger the numbers I make, the more problematic they do become. So here's what I'm going to do. I'm just going to get n by itself. So I divide by 40. Therefore, n's by itself. What I do to one side, I do to the other. Now here's the great thing, right? Order of operations. Multiplication does not come before division, only when we get to it left to right. Well, this guy falls within the same problem. So I can actually reduce this guy before I multiply him. Why would 12 times 25 become 300 when I can take 40 and 12 and pull that 4 out? And I get 3. When I pull the 4 out of 40, I get 10. Well, now I look at the 25 and the 10, I can reduce one more time. So I can pull a 5 out of 25 and a 5 out of 10. When it comes out of 25, it becomes 5. When it comes out of 10, it becomes 2. Now, remember, this guy's still in parentheses. So this 5 is still in parentheses, which means multiplication. So that's still 3 times 5, which is 15. And my denominator now reduced all the way to 2. And had I taken 300 and divided it by 40, I've reduced and reduced and reduced, and it would have come down to 15 halves, or 7.5. Now, if you choose to make that something other than a fraction in simplest form, it's got to be right. So if you turn this thing into me as 7 1/2 or 7.5, that is the correct answer, 7 5/10. But if you mess up in that mistake, please let me remind you, if you mess up in that conversion, even though all your work is absolutely right, you did not produce the right answer. Therefore, I do have to take work points off. Last one I want to do today is one that causes a lot of kids some frustration. And this is exactly why I did example number 2 and we did the fractions. Because we will have proportions that do this. 3 over n is equal to 6 1/4 over 100. So we're saying as 6 1/4 goes down to 3, 100 goes down to what number proportionally? Well, this one becomes kind of a rough one. So we're going to do cross products on this. So here's my cross. That's my first one. Here's my second one. And here again, we're just trying to make it linear so we can solve this problem algebraically. So 6 1/4 n is equal to 3 times 100. Now, yes, I know that 3 times 100 is 300. But here again, the bigger the numbers are, the more problematic they become. Well, so this goes back to this problem. I've got fractions, and I've got to divide this 6 1/4 fraction. Yes, it's a mixed number, but a fraction off of that n. If I'm going to do that, I must copy dot flip that guy. So here we go. I can't copy dot flip 6. 6 has to be made into an improper fraction. So as I make that into an improper fraction, 4 will always be my denominator. 4 times 6 is 24, and 1 is 25. And yes, that's still n. I'm just going to fill out the rest of this, keeping my linear. Now, I'm going to take this side and multiply by the reciprocal, or copy dot flip. Anything divided by itself as 1, I get left with n. What I do to one side, I multiplied it by 4/25. I'm going to multiply the right side by 4/25 to maintain equality. And now what I want you to pay attention to, out of 100, I can pull 25s out. So I can pull 125 out of 25, pull 4/25s out of 300, and I've got a 3 times a 4 times another 4. And 12 times 4 is 48. Plug it back in, left side equals right side, and you will see that 48 is my answer.